Hi guys, Levi here from Bright Young Brains. So, in terms of us working with whatever it is that we're going to be working with in algebra, be it differential calculus or just calculus in general, or just algebra in general, you want to be very comfortable with exponents and surds. As in, the way you juggle exponents and surds is a very big factor in terms of determining how comfortable are you with algebra, right? And how comfortable are you with just maths in general. So what we have here is a basic exponents and surds question, maybe not so basic. We need to solve for x here. What we are going to need to keep in mind is for us to solve for x here, we may need to think outside the box. However, apart from us just thinking outside the box, we also want to look out for mini trends or mini portions within our sum that kind of stand out. For example, here we have a base 5 with an exponent, and then this is 125. This can be written with a base 5. And then here we also have a base of 5 with x as the exponent. So for us here to solve for x, usually what you may want to do is, if your variable is already somewhat not too mixed up with your sum, you don't want to just juggle. Okay, what you may want to do is try and simplify this as best as you can, and then involve the x at the end, right? So the first thing we may want to do here is, as said, we may want to change what is inside here. The first thing we can already see here is that anytime you work with the square root, as long as there's no mini 2 written there, as long as there's no number written there, there's a small 2 there. And then this whole thing here can be rewritten with the 2 under the negative 1 there. So it will look like that. On the right hand side, we still just have 5 to the power of x. On our left hand side here, we already said that this we can rewrite it with 5 as the base of our expression. If we do that, this will have to be 5 to the power of 3. There we go. What we have written out here should not look funny or should not seem funny, because all we've done is we've rewritten 125 as 5 to the power of 3. This was initially to the power of negative a half anyways, and the whole thing was to the power of negative 4 over 3. So we have not done anything funny. What we have done for ourselves though is we have given ourselves a platform for us to execute a few exponential laws. For example, here this is a base to the power of an exponent, to the power of an exponent, to the power of another exponent. So it just means you need to multiply all those exponents out. If we multiply all those exponents, you end up with 5 and 5 to the power of negative 1 with 5 to the power of 9 over 8, because we just multiplied all those exponents. It's just a simple exponential law. Here now, we are now going to execute another exponential law. Here we can see that our bases are the same, right? So we basically just need to add our exponents. Here, remember, we're not dealing with multiple bases. We're just dealing with one base. It has an exponent to the power of an exponent to the power of an exponent. I'll repeat that slowly. So here we're just working with a base to the power of an exponent, to the power of an exponent, to the power of another exponent. So these we just multiply them together. Here though, we have two different expressions with the same base, and we're multiplying. So here we add the exponents. This is basically going to give us 5 and 1 over 8. So here we can now see it has made things a bit simpler, because here we can clearly see that these two sides, for them to be equal, x has to be 1 over 8. There we go. That's it. If this question was a bit fishy, right? Say on the right hand side, we had square root of 5 there. Funny thing is, nothing on the left here would change, okay? Because here we would just need to keep our square root of 5 all the way till the end. And then here though, we know that we don't have a final answer. In a scenario like this one, all you would need to keep in mind is, firstly, there is a 2 here, right, with the 1 inside where the 5 is. So before you can do what we did, as in to have the same base and everything, all you want to keep in mind is our square root symbol. You can rewrite it with 5 to the power of a half. And then here this is just going to say 5 to the power of a half x. Now this is obviously where things get simple, because all we can now do is our bases are the same and we're working out an exponent, so we can just drop them, meaning we can just end up with that. And then here, because we're solving for x, we can just divide both sides by a half, which is giving us a final answer of a quarter. So another simple question, right, or not so simple at first glance, will be asking us to show that the left hand side is equal to the right hand side. With a question like this one, we want to keep in mind that basic surd laws will always apply. So the first thing you can do for yourself is put all these values in your calculator, so that you have, normally with questions like this, you will find out that they each have a common factor in some way, and you will only be able to find that out with your calculator. So we're going to put each of these in the calculator and then lay them out to see what that common factor is, because that's like a mini trend with questions like this. There we go. So we can clearly see that all of them have at least square root of 3 in them. So what we can do here, before we involve the left hand side, we can take out square root of 3 as a common factor here. This is clearly giving us square root of 3 over square root of 3. That's just a 1. Here, this is saying xy times xy to the power of negative 1. We know that anything with a negative exponent, you can write it on the denominator position, whether or not it's on its own or whether it has like something next to it. As long as something has a negative exponent, you can just take it down, right? So here what we have in essence is just xy over xy, and we know that xy over xy, that's just the 1. So left hand side is definitely equal to the right hand side, and we didn't do anything funny here. It's just a matter of keeping in mind that with some questions, especially with exponents and surds, there are just some trends that you need to be aware of. So we have here a question, or an expression rather. This would easily be asking us to just simplify until we cannot simplify anymore. The question would simply just be simplify, right? However, when you simplify, you want to take it as far as you can, usually until you maybe have like one single value or something like that. So firstly here, we can see that this is a basic question, in the sense that here we know that at the top we have 2 to the power of 3 with the 2 to the power of a there, minus 4, and then here this we can split up into 2 values, and then down here this we can also split up into 2 values. So these, the top and the bottom part expanded, looks like this, right? And here we can clearly see that 2 to the power of a is a common factor, so that we can just take it out, right? This is then showing us that these two can cancel each other out, and then at the top here we have 3 minus 16, which is just negative 13. That whole value over negative 1 is just showing us that this simplified is just going to be a positive 13 there. So exponential laws, exponents and surds, really, they just have simple trends that you want to be able to work with.